Good morning. Once again, we are back to our previous topic, that is something called the Thevenin's theorem. In the previous class, we have discussed the basic nitty-gritties of this theorem. Now, in this class, we are going to see in detail how any circuit can be converted to a equivalent Thevenin's circuit. So, see, this is the basic circuit, which first of all the elements of the circuits need to be linear as well as bilateral to start this analysis procedure. Next, see, in this circuit there are two voltage sources, two resistances named as V1, V2, R1, R2, and there is another resistance called the RL. The nomenclature of this thing has been done in a different way purposefully. So this RL is a very important parameter while judging or analyzing this circuit. So what is RL? RL means load resistance. Any appliance that basically consumes energy can be represented as a load resistance. For example, a motor, a generator, a motor, a fan, a light, anything can be basically represented with the use of a resistance RL. But in this case, theoretically, how are you going to distinguish between a random resistance with two RL? So see, RL is our point of interest. In this case, we have to analyze either what amount of current is flowing through this RL, or what amount of voltage is being generated across the RL, or maybe you have to calculate the power dissipated through RL. Anyway, RL is our point of interest. The whole thing basically revolves around RL. So that's the thing by which you can understand or you can distinguish from a random resistance to RL. So for example, there is a problem given. In that problem, you are asked to calculate what amount of voltage has been generated across RL. So from that question, from that particular moment, you know that that particular resistance is our point of interest. So from that you can simply conclude that that resistance is our RL. While doing this analysis procedure, the first task is to understand or is to identify the RL. That part has already been taken care of. So what we have to do? The next task is to remove the RL from the circuit. So let's do that. We are removing the RL from the circuit by an open circuit. Now see, in this circuit there are basically three parameters. One is a voltage source and two resistances. The resistance RL has already been identified and taken care of. So now we are left with only two things. One is to calculate the RTH, second one is to calculate the VTH, the two very basic parameters. Now first let's come to RTH. What is RTH? RTH is nothing but the total internal resistance of the circuit, or rather the property that basically represents the circuit physically. That is RTH. So how are you going to calculate RTH? RTH calculation is a very standard, there is a very standard procedure to calculate the RTH. First, you have to remove all the sources by their internal resistances. Now, as you are all familiar with this topic, an ideal voltage source is considered to have an zero internal resistance, while an ideal current source is said to have infinite internal resistance. So that's why whenever you replace a voltage source from a circuit, you replace it by its total internal resistance, that is nothing but zero or short circuit. And whenever you replace a current source from a circuit, you replace it by an open circuit. So in this case, as we are having only voltage sources, so let's replace them by short circuit. Now what is RTH? RTH is the total internal resistance of the circuit, while by removing all the voltage sources from the circuit. And there is another very important aspect of this thing. You have to calculate the resistance, this resistance RTH, from the open circuited load terminals, and you have to look into the circuit from this open circuited load terminal. Now what does it mean by looking into the circuit from this open circuited terminal? It means nothing. From the calculation point of view, it means that at the end of the calculation you should be standing at that particular point. That means this open circuited point. Now if I end my calculation this point, according to your judgment, where should I start? Definitely from the completely opposite side of the circuit. That means from these ends, correct? Now from these ends, if I have to check, see this R1 and R2, both of them are in parallel. Because see, if a current is flowing through the circuit, in this case, though it's not possible to there is no possible flow of the current in this circuit. If I, for example, theoretically apply I current from this particular point, this I current is getting divided in this point, and it's following two paths. One is this, one is this. So these two paths are basically parallel to each other. And after this point, again, they're meeting and they're getting through these points. This is only a theoretical calculation. As you can see, there cannot be any current flow through this open circuit. So that's how you calculate the RTH. You start from the very end of the circuit, and at the end of the calculation, you will be reaching to the point of your open circuited load terminal. So in this case, basically the resistances should be R1 parallel to R2, R1 R2 by R1 plus R2. So that's it. You have already calculated the RTH. And again, I should say this RTH represents the physical properties of the circuit. Why physical properties? For example, if I change any of these two resistances, or in a much complex circuit, if I change any of the resistances, this RTH is going to get changed. So that's why RTH takes care of the physical properties of the circuit. Fine. Next, there is the last thing that we are left with is called the VTH, and this is also called in some books and by some eminent professors as VOC, or the open circuited voltage. So what does it mean by this VTH or VOC? In this case, again, we have to start from the beginning. The voltage sources will be there. And all you have to do is to calculate what amount of voltage we are getting at this open circuited terminal. The terminal that has been open circuited by removing the load resistance from the circuit. So that you can calculate by using anything you prefer. It may be Kirchhoff's current law, Kirchhoff's voltage law, any circuit analysis technique. All you have to do is to calculate what amount of voltage is being generated at this particular open circuited point. Now once you are done with the calculation, once you get this VOC or VTH, see from this circuit you have got all the parameters. You know what is RL, you know what is the value of RTH, and this RTH is also known as RN, and you have also got the VTH. Now if you need to calculate what amount of current is flowing through this resistance RL, it's a very simple task. There is nothing but I, if a current is I is flowing through this, is equal to VTH divided by RTH plus RL. See, if we have tried to calculate this whole thing from this circuit, it would have taken a much more tedious procedure. But in this case, once you get this RTH, VTH and RL, it's just a very simple task to calculate what amount of current or voltage you are getting across this RL. Also the power. So more or less that's it for today's class.